If you're looking for ways to create variants of your virtual ECU without running it in a simulation environment or triggering a new software build, stay with me and keep watching. Hi, my name is Daniel and I am part of the vVIRTUALtarget development team. Today I want to show you the use case for persistently changing the calibration and parameter settings of your virtual ECU. There are different reasons why persistent calibration and parameter value changes optimize your adherence to your requirements. If you define different parameter sets for your vECU, you can validate the functional behavior of your system under test in multiple variants. The offline calibration use case of vVIRTUALtarget provides this possibility without the need to rebuild your complete virtual ECU over and over again. We simply modify the parts that differ from the previous variant directly in the SUT's DLL. For this purpose, the CalibrationBenchVise tool is part of your vVIRTUALtarget installation. CalibrationBenchVise implements a XCP on Ethernet slave interface. After starting CalibrationBenchVise, you can establish a XCP connection to your XCP master tooling. The connection is used to change parameters within your SUT without rebuilding the software itself. Enough theory, let's get the demo started. We start CalibrationBenchVise from the command line. We define the IP host address and port number of the XCP slave interface. And of course, we reference our SUT's DLL before executing. Now we start the XCP master tooling, in our example CANoe. In CANoe, we use the XCP panel to define the counterpart to CalibrationBenchVise. The XCP panel requires an A2L file that describes the parameter structure of our DLL. This is already available in our example. A2L files can be created and updated using the ASAP2 toolset from Vector. We can integrate the A2L file update into your vVIRTUALtarget build process and trigger it automatically. We start the CANoe measurement. Go to the XCP panel and hit the Connect button. This establishes the XCP connection between CANoe and CalibrationBenchVise. Changing a parameter value within the XCP panel does trigger an XCP download command to CalibrationBenchVise, which will now change the parameter value persistently within our SUT's DLL. Let's change the value for this parameter here. We see that it worked. Let's stop the measurement. But is the change persistent? We can verify that by going through all the previous steps again. Start CalibrationBenchVise, start the CANoe measurement, and establish the XCP connection. We can see that the new parameter value is still present. This was a quick demo of our offline calibration use case. If you have any further questions, please consult our Vector knowledge base or contact my support colleagues. Thank you and goodbye. In case you're interested in more helpful vVIRTUALtarget features, please check out our other videos. Don't forget to subscribe to the Vector Tech Tutorial channel and activate the bell.